Hello everyone, in this video, I'll demonstrate a Cypher query running in Neo4j desktop. The goal of this query is to find pairs of actors who have acted together in at least 2 movies of the same genre. We'll look at how the query works, see the results, and understand why Neo4j handles this type of relationship-based query so efficiently. In our movies database, here are the nodes and the relationships. I have initially saved here the query. Here's the Cypher query. It starts by matching patterns in the graph, each actor node connected to a movie node through the acted in relationship. The movie is also linked to a genre node through the in-genre relationship. This structure lets us easily find actors who share the same movie and genre connections. The match clause looks for patterns of actors connected through movies and genres. The with and where parts filter pairs that share at least 2 movies. Finally, the return statement lists the actor names, the genre, the number of shared movies, and their titles. Let's run the query. Neo4j scans the graph, traversing connections directly between actors, movies, and genres. Here are the results. We can see actor pairs like Meryl Streep and Anthony Hopkins appearing under the drama genre, with 2 shared movies, The Iron Lady, The Silence of the Lambs. Each row shows a unique pair of actors, the shared genre, and the list of movies they acted in together. Now let's look at the graph view. The graph view here visually represents the relationships. Here we see the actor who acted with another actor for this particular genre and movies. What's powerful is that Neo4j doesn't need to join tables like MySQL does. Instead, it simply follows the relationships stored in the graph, which makes this kind of traversal extremely fast. Let's take a look at the query profile. The total execution time is around 3 milliseconds, and the database performed only a few node and relationship lookups. There's no need for costly joins or foreign key matching. Neo4j navigates relationships naturally. That's why graph databases like Neo4j are a perfect choice for social networks, recommendations, and connected data analysis. In comparison to MySQL, which must combine multiple tables through joins as shown in this script. Let's run the query and take a look at the query profile. The total execution time is 12 milliseconds. In summary, this Cypher query demonstrates how Neo4j efficiently handles relationship-heavy data. With just a few lines of Cypher, we were able to explore actor collaborations across genres, something that would require complex joins in MySQL. This showcases Neo4j's biggest strength, fast, intuitive graph traversal. Thanks for watching.